The next speaker will be Martin Levy. He will speak about Cloudflare update.
Thank you. It is a pleasure to be here, and even before I start, thank you to the translation. It has been quite excellent and very useful for me. So, I want to talk about IPv6, and I have spoken a lot about IPv6 in my career. But I'm going to add some other things that we're doing that hopefully will be useful for people to hear about. And I have a lot of extra slides on this deck, and the deck is available on the ENOG website. So when you see me skip slides, don't worry, you can find them. So I want to start with the end of the story. For years and years, we, as an industry, have spent time trying to enable v6 and talking to people. So the end story is that at Cloudflare, after many years of testing, we decided just to simply enable everything that we had on our systems as v6 and removed from the user the choice of enabling or disabling v6. We decided this was the easiest way to move forward. And we did that for about 6 million websites. And that's the story I'm going to tell. I'm going to take some extra time and talk about DNS and DNSSEC. But there's really nothing much more to really say except for to talk about the technology we chose, because again we made it very simple for the end user by design. And if you sat through the tutorial yesterday on DNSSEC, I say this politely, it is hard. It's worth doing, but it takes time. So very quickly to talk about us just from a high level, we run over 100 sites around the world as a content delivery network. We do content delivery, we do DDoS mitigation for our customers, we obviously do DNS, because I'm going to talk about that. But the key part for us was to enable IPv6 everywhere, to obviously enable DNSSEC everywhere, and to do that for all of our customers and make that as easy as possible. I'm going to delve into some of the underlying results of doing that, which I hope will do what I want to do, is to convince you to take and continue this journey to v6. So, pardon me scooting through some slides. Let's get to the part we care about, the technology side. So, the parts I'm going to talk about are the backstory about what we did for v6. We'll talk about DNSSEC. And at the end, I'm just going to add a little pitch, which is some work we're doing in the IETF. So in a content delivery network, you deal with a very simple connection to provide content to the end user. A connection to the original web server, the origin where the content is created, and a connection from the content delivery network out to the eyeball where the data is consumed. And those two connections, those two TCP connections, are in fact separate by design, which means that you can have a v4 origin, a v4 web server, but use your content delivery network to enable v6 as well as distribute around the world. We did this, and to be honest, a lot of other content delivery networks, our competitors, did the same. But when we started this journey many, many years ago, we did what most companies did. we put a switch on our control panel for every user, a switch that said enable v6 or disable v6. And as you can imagine, when we started, the default was off, because that's how you start, very safe. And we told our customers, go there and change the switch, enable v6, that's important. Did they? Not many. So if you turn the switch off, you end up in just a v4 world. That's how we start the game. And to be honest, some people turned the switch on, they turned it off, they turned it on, they thought that was a problem. But the key part of my story is most people did nothing. They never visited this page. If they actually turned it off, as of last year, we decided that we didn't really like that. So we put up a cute message in English, which I have to admit is probably translated but badly in other languages. But basically it said, don't do this. So what did we do? So last year we decided to take this switch and flip it, to change it, to make the default on as opposed to off. Now this may sound obvious, but you have to really, as a service provider for a large number of websites, you have to do a lot of testing, and we did. But this is how the code operated. This is what we did. We turned around, and keep in mind we were running 5 million zones, hitting 6 million zones pretty much at the end of this process. So last year, we wrote a very simple piece of code, and it simply said this: if the end user has never gone to this page, has never touched this switch, maybe they didn't know it existed. Maybe they didn't realize that it could have been on instead of off. This hopefully makes sense. And so we went around and said, if you've never touched this switch, we're going to flip it on, because this seemed to make the most sense. We did it slowly, and then we sped this up a little bit. And in speeding it up, we ended up doing about 100,000 domains a day, which we thought was a fairly acceptable rate. This was going to take us a while to go through our customer base, but it was important for us to make sure that we didn't just turn on multiple millions of zones at the same time. And the code, as I said, was very simple. As we started, we didn't really talk about this very much, but Twitter being what it is, it shows up on Twitter. A few people started tweeting, hey, the Alexa million, something's happening. There are more, who's enabling v6? And we still hadn't said anything. But the graph kept going up and up and up. And finally, I want to show you the results. This is from Eric Vink's graph, which unfortunately stopped in about March or May this year, because the Alexa million list stopped being published for free. And I think he didn't want to pay for it, which I don't blame him. So this graph shows when we started. So of the million top zones, we managed to make this graph nearly double in size. And therefore, obviously, people noticed, and we then talked about it. What was important was we essentially got no support issues during this time. And this is really the key message about v6. We are dealing now in a much more reliable environment. We're dealing with the ability to deliver v6, but at the same time, we are dealing with real users on mobile networks and fixed networks around the world who are consuming v6 bits. So this isn't an exercise that was would have been trivial because no one was using it. It turns out many people were using it. Now, like most people, we have this, this graph that goes up and up and up, bandwidth-wise. This, again, made perfect sense. And I'll talk a bit about where that bandwidth goes. But we made one other important decision after doing this, and we held off until we had finished. And that was to remove the switch, to remove from the end user essentially the ability to go back to a v4 only world. And this took a lot of effort, a lot of thought, but in the end we did it. So the before picture of our control panel and the after picture are somewhat obvious. Before there's a switch and after there isn't a switch. That is the case for 99, a very large percentage of our customers. There are a few large partners that still have access to this, but not the general user. And this has continued now. I'm telling you a story that happened last year, and we have still sat monitoring this, both from a support point of view and obviously from a traffic point of view, and we're very happy with the results. So the key message is that if you can take this level of diverse websites, from trivial blogs through airlines, through banks, through sports sites, through whatever, that you can actually take v6 to the next level for the hosting world. Okay, so I'm going to talk a little bit about who's driving the traffic and show you some of the information about where we're seeing traffic go from a very simple point of view. So this graph has two axes. On the X scale, from where I'm standing to the end, is more and more bandwidth. The size of a network. As a network gets bigger, they sort of move across in the X direction. Although there's some two-letter acronyms in there, I'll give you an example. China Telecom is CT, TT is Turk Telecom, CU is China Unicom. But I've just mentioned networks that are 0 on the y-axis. The y-axis is the percentage of traffic that we ship to that network that is v6. And what you will see is, yes, there are definitely networks in the 0. In other words, they don't have v6 enabled. This effort was useless to them. But at the high end, we see networks that do have v6 and have mature v6. So we see T-Mobile in the USA, Verizon Wireless in the USA, which are fairly high, Sky in the UK, AT&T, there's some Deutsche Telekom in there, Telefonica in Peru is slowly coming up here, Orange in Poland. Unfortunately, I just don't have a network here in Belarus that I would point to, and I hope that that would change one day. But interestingly, if you look up at this graph as you go higher and higher, you see Facebook. And this sort of confused us for a moment. And then we realized after talking to Facebook exactly what was going on. Every time you post a website and you get the headline and the picture and it goes into your stream of data, that's Facebook being an end user and querying, scraping the site and generating the information. Facebook, in fact, very much prefers v6 over v4, and therefore they actually have a much higher percentage than most people. A few other ones right at the top there are some networks that do some extreme biasing towards v6 as well, but not as big. So this graph made sense, and actually we were quite happy with it. When we looked into the rest of the data, once we started with this larger amount, we noticed that mobile was the winner. There was more traffic going to mobile devices than there was tablets or desktops. Interesting, if you look at the mobile devices, iOS and Android, pretty close. And that makes sense, actually. They've both done work in protocols like XLAT 464 and other things. I have something on my screen here. I think it's backup failed. Okay, all right, no problem. Interestingly, just for those people that care about this, if you look at Windows and v6, you see an interesting story. Yes, you can get Windows XP to talk v6, but you truly shouldn't. You should turn the machine off. If you go down to Windows 10, you start seeing a nice bias towards v6. This seems to make sense. All right, where in the world? So we looked at DNS queries because that was sort of interesting. And look at this like deep European solid green. You can see this in the US as well. But in Europe, this is a nice, mature environment. We've still got a lot of work to do in Africa, some good work in Latin America, et cetera, et cetera. All right, so that's v6 for the moment. And I want to talk a little bit about DNSSEC. I realized this is actually probably useful. I'm going to just hit a few simple points. We had to do DNSSEC at scale. So everything you learned yesterday in the tutorial is valid, but think about how to do that at a very large scale for a very large number of zones. So this was very much about automation. We put a lot of effort into this, and it was something that we have an absolute dedication to, in the same way that we looked at V6. But DNSSEC is a much harder beast to do. We needed to do it on a large customer base, and we needed to do it on the fly. And I can explain a little bit about that. If you're familiar with DNS systems, a lot of times you have a file that contains your DNS records. We don't have that. We run everything dynamically in a database, and it's all pushed out to the edge. And in fact, some of the basic DNSSEC techniques turned out not to be usable by us. So we had to do things on the fly. And that also meant we had to do things quickly. The classic RSA protocols, the algorithms for encryption, just were too slow. But luckily, and I put the IETF RFC at the bottom here. Luckily, ECDSA, the ecliptic crypto algorithm, sort of came out at the right time for people like us. We worked out how to make it much faster, as did others, and we worked out that we could sign on the fly, meaning that at the edge of our network, at all those dots on the map, we could do a DNSSEC response and encrypt it right at the point that we were sending out the DNS response, as opposed to doing it ahead of time. Now, why ECDSA? There's lots of good information. I've got another URL on there. But let's look at one key point. When you're encrypting something, it turns out if you can build something that is smaller to ship on the wire, it has two values. It has two useful values. One is that you're moving less bits, and that may sound obvious. But in the DNS world, you have another problem. DNS is 30 plus years old, and it was written for a different internet than you and I use today. But in the protocol, in the base of this protocol, is limitations on the size of a packet. And that size actually matters because you want to be successful by enabling DNSSEC and not trigger anything that causes a hiccup, the particular packet to be dropped. So it turns out that the size of the packet was just as important to us as it was just to enable DNSSEC in the first place. We also had to solve speed. So we hired this crypto guy from Intel, and he just rewrote a whole bunch of code. And you can see, oh, I'm sorry about the bad formatting, but you can see here that the op level for ECDSA is much improved over the regular RSA signing. Now, I'm sort of skipping a lot of the story here, and I will admit that there's much more to talk about making this decision. And one of the most important things was that when you change a crypto algorithm, you also have to make sure that anything receiving what you're sending out will, in fact, decrypt what you're sending. And if that isn't the case, then you have a problem. There's a whole blog entry on how we decided that time had come to push these changes with modern-day DNS servers. Okay, the last subject, which I'll talk about, is TLS. So the other thing that is important about moving web pages is that you make sure that you're using the latest and greatest crypto, both in the way that you package and the way that you encrypt. And TLS 1.3 is the latest out of the IETF. It has improved 1.2 dramatically. And I'm going to just simply deal with a couple of high-level points which we delivered in software, and there's a lot more as I said, about our blog about the technology. But this is what TLS used to look like: a handshake. You would ask for a web page. As a server, I would respond. You would then respond. I would respond. You would respond. I would respond. And then finally, we get to talk and actually move pages. This is not very efficient. But this diagram is better than 10 years ago. What TLS 1.3 does is it reduces dramatically the handshake between two sides, which will speed up the connection. What's even better is that if you can throw a tag into the client, you can even reduce that further. In other words, if you already have a session between two end nodes, you can keep a token around, a token, which will then enable you to restart. But today I wanted to just sort of convince you why new software is important in the crypto world. And it's this simple. If you spend any time looking online at what is going on in the crypto world, you will notice that there are bugs. And some of them are bad. So if you look at TLS 1.3, it is actually important to understand what has been removed. We have accumulated over the years many, many different capabilities inside our crypto libraries that exist on our mobile phones, on our laptops, in our servers, everywhere. But the reality is no one had the guts to sit down and do a review and decide what should stay, what should go. So I did a review here. This is a very quick review of what disappeared. And I'll point to two that may be very obvious. MD5 and SHA-1. MD5 is amazingly simple as an algorithm, but it's inappropriate for this day and age from a cryptography point of view. SHA-1 has been proven to be the same, although you have to be a bit of a crypto geek to understand that part. All of the red there is the generic names of various bugs and problems that have been solved in the crypto libraries over the years, and they've all can be related to something inside the removed column from TLS 1.3, and that's a good thing. So, based upon Ignace's talk yesterday, I decided to add one more slide to this talk. This is a piece of email from the IETF mailing list, and I'll paraphrase the first part and the response. The first part is, I'm somebody who works in the financial environment, in the technology, but we have found that this new protocol definition, TLS 1.3, is a little too good, and we won't be able to decrypt in our banking environment the information that's flowing. And we need you to not do this. The response on the mailing list from somebody in the environment, I'll paraphrase, no. That is not the goal of the IETF. And so the IETF literally is in the position of making sure that the protocol is protocol correct, protocol safe. And so there was a lot more to this mailing backwards and forwards, but this is going to stay as is. Okay, I only have a couple of minutes left, and my last set of slides were about work in the IETF and IPv6, but I'll skip that, and if there's any questions, use that 2 minutes for questions. And the slides, as I said, are online if you want to get to the rest of them. I'll skip through to the end. Oh, sorry, one more thing. I did add this. There was a discussion yesterday about Taylor Swift. Who knows who Taylor Swift is? Yeah, a couple of you are admitting it. There's a few more, but you're not putting your hand up. Her website is IPv6 enabled. That was all I wanted to say. So, you know, that's, as they say, a good thing. All right, thank you very much. I appreciate it. I know it was very quick, but as I said, there's much more information online. Thank you.
Thank you for your presentation. Вопросы?
Включить? О. Hello, Martin.
Hello, Martin. I like Cloudflare company a lot, and the solutions, I like it. And the solutions it offers. And I also believe that DNS hosting in Cloudflare is one of the best ones. But quite recently, I noticed that Cloudflare does not support DNS zones of ARP for IPv4 and IPv6. I understand that ARP zones are not about web that Cloudflare is dealing with, but nonetheless, we will appreciate seeing the support of ARP zone in DNS hosting, if possible.
An excellent question.
I agree with you. And you have answered your question because we are about web hosting, but DNS is important to that. So you can use us for DNS with or without web hosting. But reverse, the ARPA zone, is not about web hosting. But I think there's still a requirement for this. If we do it, you will detect if we've done it. Because at the moment, the IP addresses on our network do not have reverse DNS, because our DNS servers do not support it. So when you see us have reverse, then you will realize that we have taken that step. And like all things, I'm sure we will announce it. But I'll take it back. I like the question.
Еще вопросы?
Do you have any other questions to ask?
Which software do you run DNS?
The software is internal, written many years ago, and modified to the point where sometime by next spring, every line of code will be replaced. It's written in Go, the language Go. It is written as an authoritative name server, because that's what we do. And it is distributed to many tens of thousands of machines around the world that deliver the bits to the outside world. It has the DNSSEC code in it now. It has the backend database code. Bits of it have been put on GitHub, the GitHub Cloudflare account, but most of it, of course, is internal, proprietary. And it has the speed that we need for being able to move things for DDoS mitigation and also for delivering this many queries.
Thank you. I just asked because dynamic DNSSEC.
It's hard, yes.
Thank you.
Thank you.